So we are doing application of P-N junction, like when you are using P and N together. I hope all of you have watched all the previous video, and if you didn't, you can't correlate easily. Anvita, what
Yes, sir.
happened
I have
in,
to watch it.
okay, Pratigya, you attended all the classes, right?
No, sir, one plus I'm not attending.
Okay. So last class you were there, and tell me what happened in PN junction.
वहाँ पर रिवर्स बायस था.
By the way, biasing means you have to note down whatever I am saying. Biasing means application of external voltage. Application of external voltage. That is biasing. हाँ हाँ प्रतिज्ञा continue.
मैं ठीक से बोल नहीं पाऊंगी, मतलब थोड़ा थोड़ा.
हाँ चंदना. So let me explain you. Then you write. Listen carefully. In case of P type of semiconductor, you have majority charge carrier holes. In N type of semiconductor, majority charge carrier are electron. When you apply external voltage, these majority charge carrier will move. Okay. It depends how you apply voltage. How you apply voltage is biasing. It could be two types: forward biasing and reverse biasing. Forward biasing and reverse biasing. In case of Sarah, turn on your camera.
Yes, sir.
So I said whenever we apply any kind of voltage, then there are two different ways. It could be forward biasing or reverse biasing. Forward and reverse. What is the meaning of forward bias? If positive terminal of battery is connected to the P side of semiconductor, then it will be forward bias. Okay. Example, you can see it here. P and type PN junction. In forward bias, this is the symbol of diode. Why diode? Because you have two semiconductor together. P-type semiconductor and N-type semiconductor. P-type triangular shape and N-type one straight line. Okay. In case of forward biasing, you can see P side is attached to the positive terminal of battery and N side is attached to the negative terminal of the battery. Negative terminal of the battery. So positive terminal is known as higher potential and negative terminal is known as lower potential. And positive terminal P and higher potential and negative terminal attached to N, then lower potential. This is forward bias. This is forward biasing. Bring your camera. Sarah, so what do you understand by the forward bias? Your, your camera is off. Oh, sorry, your mic.
So P is connected to positive terminal and N to negative.
Correct. So if you understand this, Chandana, what could be the this reverse bias?
Sir, P-type is attached to connected to the negative terminal
Uh,
and N-type is connected to the positive terminal.
yes. If you know forward biasing, reverse biasing will be exactly ulta. Now you can look at this diagram. If you understand this, Varinder, why there was layer between P and N? Why
The
there was a
depletion layer.
middle depletion layer? Uh, Pratigya, what is the role of depletion layer?
No, sir. Not remember.
Jordan, what is the role of depletion layer?
So I haven't watched the videos yet.
Okay. So remember, example, P side have lot of holes and N side have lot of electrons. Correct. These two side, electron and hole want to come together. This electron and hole want to come together. When they join together, they will settle in the middle. And this part, thick layer, is known as depletion layer. It is a stable region, and this stable region will try to prevent movement of the charge gap. What happens, Sania?
So just a question.
Yeah.
So depletion layer is only present in reverse bias or is it present in
No,
both?
depletion layer is present in the both the situation. Thickness of depletion layer can vary in forward and reverse bias. You have to
Okay,
write
sir.
whatever I am saying. That's why I'm speaking slow. Let me know if you were not able to finish the sentence.
So can you repeat once?
P P side have holes as majority charge carrier. Right, in short, it's not like exactly the same wording, but write the same thing. So P semiconductor have holes as majority charge carrier. And semiconductor have electron as majority charge carrier. These two charge carriers will try to come close to each other, so they form a neutral and stable molecule. When they come together between these two semiconductors, so they will form a layer. This layer is known as depletion layer. This depletion layer is neutral and stable. And this depletion layer mainly prevent movement of charged particle from one side to another side. Understood, everybody?
So can you just repeat the function? So I haven't written the full sentence.
So function of this electric field is to oppose movement of electron and holes. Second, this layer will be formed between positive and negative side in the middle. That's why see, in both the situation, you have this middle layer. That layer is known as depletion layer. That layer is known as depletion layer. You can see here. Same depletion layer form potential, that is barrier potential. Okay? Barrier potential or depletion layer. This thickness is very, very small, like 0.1 micrometer. Thickness of this depletion layer is very low. But uh, this thickness is different in forward and reverse bias. This depletion is different in case of forward bias and in case of reverse bias. Why? Because, example, if you have forward bias, then P side will have higher potential, like this. P side will have higher potential, and a holes and positive side will try to repel each other. Same way, electron and this negative side will repel each other. So they will move across. And when they move, the thickness of depletion layer will reduce. The simplest answer is thickness in case of forward bias less. Thickness in case of forward bias is less. Okay. Thickness in the forward bias, it is less. So in case of reverse bias, it will be more. In case of reverse bias, it will be more. Um, who will tell me? Chandana, why? Why in case of reverse bias, thickness of depletion layer is more?
So due to moment of charged particle.
Because if it is reverse bias, example, this is P side. This P side have negative charge. Holes are present on the same side. So these holes will try to move toward the negative and their width will increase. Makes sense? Their width will increase because they are moving toward the opposite side. Look at this diagram. This P have negative charge. Now holes want to move toward the negative charge. Electron want to move toward the positive charge. It means this thickness will increase. Anybody have doubt? Let me know. I already taught this, and all of you are supposed to finish the previous video. Remember, today we are doing application of this part, application part. If you don't understand P and N junction, if you don't understand how this depletion layer will change in case of forward and reverse bias, application is impossible to understand. Anvita, so if thickness in reverse bias is more, what should be the barrier potential, more or less?
If the thickness is more,
If thickness is more,
uh, it will be less.
answer is it will be more.
Okay.
Why? Imagine this was the thickness. Now, if you increase the thickness, then barrier will be bigger, then barrier potential will be more. Understood? And remember, only for today's class, I am saying like that. Otherwise, I will write proper on the screen and I'll send you notes. But for every class, you are supposed to turn on your video. Right? So, Sania, what will be the potential in case of forward bias, barrier potential?
Sir, it will decrease.
It will decrease. Why?
Sir, because the thickness is less.
Because thickness is less. So less thickness, less potential, and less potential, electron can easily move. Electron can easily move. Okay? That's why you will see your thick barrier potential in case of forward bias is less, so it will be negative. Is it written in the notes? Yes. Yes. No, it's not. It is like that. In case of potential, it will be negative, and in case of reverse bias, it will be positive. How? Example, total potential was V minus V not external potential. Because external potential reduce the overall barrier. So minus sign. V minus V naught external potential. But in case of reverse bias, thickness will be more. So potential will be added. V plus V naught. Understood? Less potential in forward bias, so negative sign, and more potential in reverse bias, that's why positive sign. Jordan, you are not writing.
So I've written it down, sir. When you said it, I
This
wrote it.
positive V minus V naught, V plus V naught.
Yes, sir.
Okay.
So V minus not is for forward one.
Yes, because potential is less.
Yes.
Overall value. All of you can ask question in between. If you didn't write complete notes, let me know. So what happen in case of forward bias? Because thickness is very, very less. So current can easily pass through it. Like
So could you repeat?
thickness is minimum. In forward bias, current is more and the resistance is less. because you know less potential, more current.
Can you please
Correct?
repeat?
Yeah, sure. So what I said, in case of forward bias, thickness reduced, so there is no barrier. Then majority charge carrier can easily move. So forward current is more, one thing. Forward current magnitude is more. Second point, forward current is because of majority charge carrier. Forward current is because of majority charge carrier. Second point. Third point, forward current is given in milliampere MA.
So the third point,
So you understood my point? First, forward current is more. Second point, forward current is because of majority charge carrier. Third, forward current in milliampere MA, milliampere. Fourth, forward current have low resistance. Just give me a minute. Anvita, yeah. So resistance in case of forward current is very low and it is in kilo ohm. Resistance in kilo ohm. And barrier potential in forward current is low, V minus V naught. Barrier potential low, V minus V naught. everything is opposite in reverse. So put main heading reverse current. Low amount due to minority charge carrier
Sir, can you please repeat the point about the resistance?
of forward current.
Yes, sir.
So in forward current, resistance is low and given in kilo ohm. Given in kilo ohm.
Sir, if it is low, then how it is given in kilo ohm?
Kilo ohm also is very low amount. In case of reverse current, we have high resistance because everything is opposite in reverse. It will be in mega ohm in case of reverse bias. And Sarah, for you, how we did P and N type of semiconductor, forward and reverse biasing is equally important for the external exam. They will directly ask individual topic or difference between these two. So, Chandana, Jordan, last year you had a question from this topic in your final exam. Any idea?
I don't remember, sir.
Chandana?
No, sir.
Okay.
I
Then
think
you
it's
had question
not
from
there.
PN. Then you had question from PN section, I guess. Sorry, PN and
Yes, sir.
type.
Yes, sir. Different.
Because there is always one question whether uh, this P and N type difference. So probably this year there is higher chance key forward and reverse biasing difference. Okay. So we were doing reverse biasing, reverse current, low amount in microampere, very low, microampere. So you can compare same thing. Sanya, you asked my question. Ki, sir, if it is low resistance in forward current, then how we have resistance in kilo ohm? Because your current in milliampere, opposite to this resistance will be in the kilo ohm. If your current in microampere, then mega ohm, right? Direct relation with the resistance and current. Example, if current is -3, then resistance will be +3, 10 is to power +3. If current is -6, 10 is to power -6 ohm, sorry, 10 is to power -6 ampere, then your resistance will be 10 is to power +6 ohm. Make sense? That's why mega ohm. Got it? Barrier potential will be high, V plus V naught. Is screen visible?
No, sir.
Then I will show you in semiconductor dropper. Probably I did in last class. See this. These are the difference between the forward bias and reverse bias. Forward bias P is connected with positive and connected with negative, opposite in reverse. In forward bias, depletion layer is small, reverse large. In forward bias, the barrier height is small, like the depletion layer width, basically same thing. And potential will be in negative, like small. In reverse, It will be addition more. Current in forward bias is more and in milliampere. See, and current in reverse bias is less than microampere. Same resistance. We said ki when resistance is minimum or almost zero in case of forward bias, like continuous current, then it is short current, like not short current, it should be short circuit. So you correct this statement, short circuit, resistance is almost zero. And in reverse biasing, because the resistance is too much in mega ohm, so it will be like open circuit, no current is passing. So the simplest way is in forward bias is almost like the simple wire, maximum current. And reverse bias is almost insulator, negligible current. So when there is a maximum current and minimum resistance, it is short circuit, not short current, short circuit. And in case of reverse bias, too much resistance and less current, open circuit. We will use the same thing in case of your solar cell. Solar cell. And these two graphs are extremely important. First graph is given for the forward bias, which say that if you apply external potential V, your I value will increase. But if you reach up to a level which is known as knee voltage or threshold voltage, then current will suddenly increase. But remember, whatever I teach here, it will be not sufficient if you don't watch video. So after this class, your task is to finish video from PM Junction and send me notes in group. And in case of reverse bias, what is happening here? Because you are applying voltage in opposite side, so your voltage is negative. Current direction is also opposite, and current is given in the microampere. Actually, it doesn't not look like this, but it is microampere, nu A. So current is limited, negligible, very low. But if you apply too much voltage on this, what will happen? Example, you have a neutral molecule. It will release one electron, one hole. So neutral atom will break down and produce electron and hole. So because of that, there is current and sharp increase in current. This is reverse biasing. Suddenly, current increase after a voltage. VR means breakdown voltage. Tell me, guys, how many of you are feeling now कि even if you skip one class, see, look, Barinder and Pratigya, there was same picture for both of them. Barinder, तुमने notice किया था ना ये?
Yes, sir.
हाँ. So now you can feel कि you missed one class of forward and reverse biasing. And now I am taking too much time. At the same time, you can't feel like how I taught in the last class, to be honest. So one class cost you too much. So you can never compromise with your class at any situation. Understood? Reason today we are doing rectifier. Rectifier, okay, you need how it act in the forward bias and reverse bias. And we got question in NEET 2025 from rectifier. And interesting part is NEET answer key was wrong this time and they gave grace marks.
When did this happen, sir?
The people who have score less than 525, they don't care about the like if there was grace marks.
Yeah.
So actually I was getting 543 marks according to the answer key. But in the end I got 548 reason because this question from the rectifier was correct. There were two answers. There were two
So can you show
answers.
the question again, sir? The rectifier question. The same question I had a doubt that day in the paper.
There were two questions from the semiconductor. This one.
This one, yes, sir.
And so they must have changed option, but in this case, like if you change supply, you will see it will act in a different way. Full wave rectifier, diode this and shown. If input supply is positive, your voltage supply is positive, then what will happen? At time t 15 millisecond, what will be the value? I think we have to check the paper. Paper had the different thing, I guess. If t is 15 millisecond, small t value, what will be the input voltage value? 15 divided by 1000, so it will be 1.5. So sine 1.5 value will be uh, positive, and based on that positive, D1 will be positive, D2 will be negative. That was the question. And there were two options. That's why this is not a perfect question. I'll show you from the paper. Any of you have paper? I have paper also for this. I'll show you in the next class. Okay. It was a very interesting question where they chose two options and people got grace marks for this. Like who chose the right option? Only those people got the grace marks. Understood? So you can't understand any of the topic we will discuss now if you don't know forward and reverse bias. And what is the advantage? We can control the current. If you want to pass more current, make it forward. If you want to stop the current to the devices, then reverse bias. Correct? So you are using mobile, laptop, or tab to attend this class, and you have semiconductor in this because it is managing current. Correct? Next, you have Zener diode. First topic application. First topic is Zener diode. Zener diode. इसका 5 मिनट का ब्रेक लेवा Screen is not visible, na?
Now it is, sir.
Okay, so I'll show you screen. Zener Diode complete topic is written over there. I'm very hungry, will eat something for 5 minutes. You write everything, try to understand this, and then I'll explain from the scratch. Okay, so I'll stop recording and if you don't remember anything, just focus ki whatever was the photodiode, exactly opposite thing exists in the LED. Whether it is biasing, exactly opposite. Electron and holes pairing opposite to the photodiode, or how, like here in the photodiode, light convert into electricity. In LED, electricity convert into the light. So sometimes question can be asked from this for 2-3 marks. Why there is a like switching of the camera? Okay, so that's why you don't remember anything. Just write opposite to the photodiode, and you can write 3 marker question also, Sarah, especially for you. Everything is opposite to that. Any doubt, guys? Are you done, all of you?
No, sir, not yet.
No, sir.
Okay, keep writing. This is very less. Can I do this now?
Sir, just a
Yes,
question.
yes.
So,
Got it.
since the energy for red light is like almost 1.9 EV, so I was reading about it like last year, the form when they had to like try to discover the LED for blue light, it needed a large amount of energy and they weren't able to find it. What is the material for blue light then?
More energy compared to the red is because wavelength and frequency.
Wavelength and
Fre
frequency, sir.
wave frequency of the blue light is more compared to other common color like red light. So you need more energy because high frequency.
So, but then what are the materials they used?
For what?
Like for the formation of blue light, because the discovery of the blue LED happened many years after red and green.
Because the discovery of blue happened.
So, like last year when I was reading it, this topic, they were talking about red light, green light, and blue light. The years, not years, the discovery of it and the materials they used. So they've written blue light was found way after red light and green light. So I wanted to
Mhm.
know what was the material which was used for blue light's formation.
No, for blue light formation, there are different variety. It depends upon the company, how they want to produce. Are they looking for the cheaper option or like expensive option? Because you depend upon the wavelength. We know we have to create wavelength around 400 to 500 nanometer. So based on that, we take different material. There's not one, two, or 10 material. You can take hundreds of material to produce blue light. Correct?
Yes,
Example,
sir.
if our phone produce blue radiation, then every company have different material to produce the same blue light in the semiconductor, right? So, but their chemical nature is different.
Yes, sir. Understood.
Right? But I'm not sure about the specific name, but what I know is many material can produce the same thing.
Okay, sir.
Understood? Yeah. Done, everybody? If you are done, this was the small topic of solar cell. Function of solar cell almost looks same like photodiode, correct? Because in solar cell, light fall on the material, produce electricity. Photodiode, same thing, light fall on the material and produce electricity. What is the difference? Difference is in case of solar cell, there is no biasing. No biasing means unbiased. Why? Because you don't need to apply external voltage. Okay. So when light fall on the depletion layer, bond breakdown, electron and holes produce. Process is same. Electron holes produce, and they will be responsible for the current. But there is no biasing as such. No forward, no reverse biasing, no biasing at all. What happen in case of solar cell? If there is an open circuit, maximum voltage, zero current. Short circuit, maximum current, minimum voltage. Understood? Any doubt, guys?
No,
SC means short circuit. OC means open circuit. In open circuit, no current, maximum voltage. In short circuit, zero voltage but maximum current. So simply, when you light fall on the material, as you can see down, then lot of electron and holes will generate it together, and they are responsible for current. Exactly same like photodiode, but unbiased. Graph is important. This graph, open circuit and short circuit, because there is no proper forward biasing and reverse biasing. In forward, you should have graph in first chamber, right? And in case of reverse bias, you should have graph in the third chamber. But here it is fourth. Why? Because it is not forward, not reverse. Understood? Not forward, not reverse. That's why graph is unique. Unbiased and this graph, nothing else. Ask your doubt. After this, I wanted to finish everything, but because of I was expecting the pen, I didn't get pen today. It went slightly slow, and that's why I took slightly extra
So
time.
did you break a stylus?
Did I break? What?
Like pen as in like the Samsung pen or like of his paper pen?
Of course, Samsung pen.
Uh, s-
Samsung pen. Okay.
so I don't think I can get it that easily. That's the thing. I broke mine and it took me a long time to find another one.
No, 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 no. I left in my home, in my hometown, so I'll get it
Oh,
tomorrow morning.
okay, sir.
Yeah. Everybody finish these notes.
1 minute, sir.
And remember this H nu means energy, light. Light fall on the material. H nu means energy, light. Instead of H nu, you can write light also. And
Sir,
I will not
instead of
do,
what?
instead of this H nu, you can write light also. Light. H nu just below in the diagram.
Okay, sir.
Done, guys? Everybody?
Yes,
Yes,
sir.
sir.
Yes.
So that's all for this session. You send me notes